Hello and welcome back to the channel. So in this lecture we are going to discuss about a coordination service which is used for managing our distributed Hadoop cluster, which is Zookeeper. So you may ask, what really is a Zookeeper and why didn't I mention it in our previous tutorials? So it is nothing but a distributed coordination service and is used for managing large set of hosts. So as you already know that Hadoop is a distributed service which has a master-slave architecture and requires lots of commodity hardware which can work in a parallel way to process big data. And managing such a huge cluster can be a tricky task. And Zookeeper helps it for maintaining the configuration information as well as the naming and providing synchronization between our nodes, and allows developers to focus more on the core application without worrying about distributed nature of the application. So this framework was built at Yahoo for accessing their application in very easy and robust manner. But it became a standard for organized services which are used by Hadoop, HBase and other distributed frameworks. So for example, HBase uses Zookeeper for tracking the status of its distributed data. So before we go forward, let me give you an overview of what is a distributed application. So distributed application can run on multiple systems in a network by coordinating among themselves for completing a particular task in a very efficient manner. So if you have to process like gigabytes of data, instead of doing it on a single machine, distributed system will split the task in multiple sections and process it parallelly on multiple data nodes. So data nodes are nothing but will do all the groundworks and process your data. So complex and very time consuming task which will take hours to complete by the conventional system can be done in minutes in a distributed application. So basically this distributed application has two parts. One is server and the second is client application. So server applications are actually distributed and have common interface so that the clients can connect to any server in the cluster to get the similar results. So there are some benefits of distributed application. The first one is a reliability. So whenever there is some failure in your data node, it will not make your whole system down. Instead, it will assign the tasks which are failed on that node to other nodes which are available in your cluster. The second one is a scalability. So performance can be increased whenever required by adding more machine without any major changes in the configuration. And it will not have any downtime. And the last benefit is transparency. So it hides the complexity of the system and shows itself as a single application so that developers would not worry about managing such a huge distributed framework and focus more on the development part. But there are some challenges, like in Hadoop, we know that there is name nodes and data nodes. So the name node keeps track of all the application and receives the heartbeats from the data nodes, and data nodes does all the groundwork and process your data. So name node is just like a master and data nodes are slave in your Hadoop cluster. So whenever your main name node fails, that place will be taken care by the secondary name node, which is a backup node for your name node. Because name node contains all the information of your data nodes and the metadata of where that particular data resides. So Zookeeper tracks all this information and get you the details like who is the master node at that time. And whenever the master node fails, so in Hadoop cluster, if the name node fails, the Zookeeper will keep that information and assigns that task to the secondary name nodes, so that whenever the client asks that what is my master node, it will tell it who is the master node that time. So these are some services which are provided by Zookeeper. So the first one is leader selection. So it is used for electing a node as a leader for coordinating purpose. So in our case, it would be the name node. The second one is it ensures the high availability of the data registry. So availability of data is very important when one or the few nodes are down. So it takes care of that, so it makes your system more reliable. The next one is cluster management. So it takes care of joining or leaving of the node in a cluster and the node status at a real time. So it makes sure, so when there is any node failure in your cluster, so it will tell the application that the task has been failed, so that the application will take care by bypassing that task on the other nodes which are healthy. The next one is configuration management. So it stores the latest and up-to-date configuration information of all the nodes in your cluster, and it is very important. And the last one is locking and synchronization service. So it does the locking of the data while modifying it. This mechanism will help you in fail recovery while connecting other distributed applications like Apache HBase. So these are some main tasks which are taken care by Apache Zookeeper. So now let's talk about the architecture of Zookeeper. So as you can see in this figure, it shows the client server architecture of the Zookeeper. So each one of these components is part of the Zookeeper architecture which are given here. So first one is client. So clients are nothing but the nodes in our distributed cluster which access the information from the server. So for a particular time interval, every client sends a message to the server to let it know that the client is alive. And similarly, server sends an acknowledgement when a client connects. So if there is no response to the connected server, the client automatically redirects the message to the another server. And the server is nothing but one of the nodes in our Zookeeper ensemble which provides all the services to the client. And as I said, it gives the acknowledgement to the client to inform that the particular server is alive. So you may ask, what really is an ensemble? So ensemble means a group of Zookeeper servers. So the minimum number of nodes which is required to form an ensemble is 3. And as you can see in this figure, we also have the leader node and the follower nodes. So the leader node performs the automatic recovery if any of the connected node is failed, and these are elected on the service startup. So whenever the Zookeeper service starts, the leader has been selected to perform its duty, and the follower nodes follows the instruction which are provided by leader. So now let's discuss about the hierarchical namespace in Zookeeper. So this is how the Zookeeper file system looks like. So this diagram will show us the tree structure of Zookeeper file system, and it is used for the memory representation. So Zookeeper node referred to as a znode. So every node is identified by a name. So as you can see in this figure, every node is identified by a name and separated by the sequence of path which is slash. So in this diagram, we have the root znode separated by slash, and under this root node we have two nodes such as config and worker. So the config namespace is used for centralized configuration and the worker namespace is used for the naming. So under this config, as you can see, we have the app1 and app2, and each znode can store up to 1 megabyte of data. And this is similar to Unix file system, except that the parent znode can also store the data. So the main purpose of this structure is to store the synchronized data and describe the metadata of the znode. So every znode in the Zookeeper maintains the stat structure. So this stats nothing but provides the metadata for that znode. So you will understand more when we will do hands-on to access Zookeeper in a bit. But you just have to make sure that the Zookeeper's file system is similar to the Unix file system and has some specific path which contains metadata of the znode. So now let's discuss the types of znodes. So there are basically 3 major types of znodes, which are persistent, ephemeral and sequential znode. So persistent znodes are alive even if the client which created that particular node is disconnected. So by default, all the znodes are persistent if we didn't specify any. The next one is ephemeral. So ephemeral are active until the client is alive. So when the client is disconnected from the Zookeeper ensemble, then the ephemeral nodes gets deleted automatically. So we are going to create a ephemeral znode in a bit when we get our hands dirty and do some hands-on on Zookeeper. And you will see how it gets automatically deleted as well. So for this reason, these ephemeral znodes are not allowed to have a child. So if it is deleted, then the next suitable node will fill that position, and it plays a very important role in a leader election. And the last one is sequential znode. So these nodes can either be persistent or ephemeral. So when a new znode is created as a sequential one, then the Zookeeper sets the path of that particular znode by attaching 10-digit sequence number to that original name. So for example, if a znode with a path app name is created as a sequential znode, then it will change the path to app name followed by the 10-digit number which is provided by Zookeeper. So if the two sequential znodes are created concurrently, then the Zookeeper never uses the same number for each node. And this nodes plays a very important role for locking and synchronization purpose. So now let's get our hand dirty and try out Zookeeper and simulate a failing master node in our HDP sandbox. So without any further ado, let's jump into it. So our next step would be to kick off our HDP sandbox. So I have just kicked it off earlier to save some time and head back to PuTTY to connect to our Zookeeper. So once you kick off your HDP sandbox, Zookeeper will automatically start and it will does it automatically under the hood. So just log in as a Maria_dev, and to get all the privileges, just log in as a root user. So give the root password. Okay, so we just have to go to the Zookeeper path. So it is situated in cd/user/hdp/current/zookeeper-client. So if you just hit ls in it, so we have the bin directory. So just go to the bin and here we have the Zookeeper CLI.sh. If we kick off this file, we'll get into the Zookeeper command line interface and we can create the ephemeral nodes by using it and just simulate a failover of a master node. So to do that, we'll just kick off this service. So give /zk-cli.sh. So once you hit enter, and that's it, you're connected to your Zookeeper cluster. So if you hit ls and go to the root directory, as we have seen in our Zookeeper file system, as you can see, you have all the directories present for different services like storm.solar, HBase, and I'm also seeing drill as well as hive server and so many services, and it has separate directory present for each service. So let's say if you have to simulate a failover master node, all you can do is we will create a system. So we can use the command like create, give -e. So we are creating an ephemeral node now, and we will give the name of that node. So we'll give master test, and in the quotation we can give any message here. So I'll give this is my master node. Okay. So if everything looks good, hit enter, and it has created the master test. So when a client requests to get information of master node of this system, all we can do is just give get/master test, and if you hit enter, we got our master node. But you have to make sure that once you quit out of this Zookeeper CLI, this node will be deleted as it is a ephemeral node. So this is just a simulation. So in the real world, once the master node fails, you will know how disastrous it could be. But let's say if we hit just ls in this directory, as you can see, our master test has been created. But once we quit out of this Zookeeper CLI, so just give quit, and we have quitted from the ZK CLI. So once we get back again by executing the ZK CLI.sh, and now if we hit ls in the root directory, our ephemeral node which we have created as a master node has been deleted. So if the client asks what is the master node for this master test, yeah, as you can see, the node does not exist. So as we quit down from the Zookeeper, it got automatically deleted. So this is how Zookeeper works and has this like a tree-like structure file system, and we have also simulated a failing master node for our application. So if everything looks good, just quit down, and there you go. So as usual, if you have done with your work, just don't forget to properly shut down your HDP sandbox. So just go to the machine and click on ACPI shutdown to properly shut down your Hadoop cluster. So I hope you like this lecture. So please subscribe to our channel and also ring the notification bell to get the latest updates. And don't forget to follow us on our social media, which I have linked in the description below. Thanks for watching.